Hello and a warm welcome to everybody. We would like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world today. My name is Jamie, and I'm one of the co founders of Safeopedia. Safeopedia's mission is to support the EH&S professionals, operational folks, and any safety minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to those dedicated professionals for the great work they do on a daily basis. Today, we're proud to present how to select the right cut-resistant gloves. This Safeopedia webinar has been made possible by Protective Industrial Products, a preferred manufacturer member of Safety Network. Safety Network demands excellence, so demand Safety Network. It is now my great pleasure to introduce to you today's presenter, Brian McCorder. Brian is a productivity expert and safety professional with over 10 years experience in implementing and teaching safety, leadership, and productivity tools. He gained much of his knowledge and experience through over 30 years as a supervisor, safety officer, and senior trainer in the manufacturing industry at the largest fluorescent lighting factory in the world. We are also privileged to have Gary Klee join us for the Q&A session today. Gary is from the Albany, New York area and has an MBA in marketing and Bachelor of Science in Industrial Distribution. He's an experienced product manager in the category and has been with PIP for just over 10 years. Now, we are very grateful to have you sit back, relax, and enjoy the presentation. With that, Brian, please take it away.
Oh, thanks, Jamie. I'd like to thank everyone for joining us today. And special thanks to PIP for making this information available. Cut is one of the fastest growing segments of the glove market. For those who are wearing these gloves, the main question is, am I wearing the right gloves that are going to protect me for the type of work I'm doing? Our hands are pretty important to us, and workers need to know beyond a shadow of a doubt that they're protecting them. So how are we doing with this in the US? Well, thanks to a Google search, according to the US Bureau of Labor Statistics, nearly 20% of all workplace injuries involve cuts and lacerations to the hands and fingers. Annually, hand injuries of all types send more than 1 million workers in the US to the emergency room. Of those, about 110,000 will turn into recordable loss injuries. So we could definitely do better. If I go back to 2009, when I was a safety manager and trainer at the lighting factory, someone had the idea of getting a safety mascot, which was a pretty good idea. We got a life-size cardboard cutout of Christopher Reeves as Superman, and we put him in a high traffic area. Then anytime someone got injured, we put a Band-Aid on Superman in the corresponding place. So if someone got cut on their right elbow, we put a Band-Aid on Superman's right elbow. Well, about by June of that year, we noticed that you could no longer see Superman's hands. Both hands were completely covered in Band-Aids. And thus was my introduction to the search for good cut resistant gloves. We had a problem and gloves were the solution that we needed. So what are we going to look at? We're going to compare the standards, testing methods, and explain cut ratings and how to make sense of the labels. In my many years as a safety trainer or manager, I can think of 2 different times where I ordered the wrong cut level gloves. And either myself or someone noticed when, after a while of actually using them, I had misread the labels. So we're going to help you to do a better job than I've done in the past. And we'll make sure that you have the right information to choose the proper gloves for the work being done. Like I mentioned, we'll review the cut standards, PIP's own cut risk hazard matrix, which is an excellent tool that we'll get into a little bit later. Then finally, we'll look at some different gloves and just show you kind of what's out there and how you can really find the right glove for the work you're doing and for the proper environment. Okay, I mentioned that we have 2 standards we're going to look at. They are the ANSI 105 and the EN 388. PIP gloves happen to be tested at both standards. Now, while compliance is not mandated with both in the United States, end users are going to need to know how the gloves are tested and labeled in order to select the right gloves for the work being done. Now, the European Union, or EU, developed a standards and regulatory body that requires everyone wanting to sell products in Europe to third-party test to the EN 388. This makes it widely recognized internationally. Now, until 2016, the EN and ANSI standards tested gloves for cut ratings in radically different ways. This slide shows the 2 methods that were used. ANSI used the TDM 100 machine, And the EN388 used something called the COOP test. Now, in the 2016 revision of the EN388, they added the TDM machine also. They recognized that this round wheel would become dull when testing certain fibers such as glass or steel. They also added an impact test for gloves with TPR, thermoplastic rubber protection. And you can see on the EN shield the placement for these new things that they added. Okay, when they're testing a glove, they're going to take a 2-inch section of the glove to sample to run through that machine. Now, when you have a glove like this that's coated on one side and not coated on the other, what section are they going to use for their test? Well, the answer is they're always going to use the coated side because obviously that's going to affect that cut score. Now, the interesting thing is not only could it raise it, which makes sense, we do have an added layer of protection, but it can also lower the score. Interestingly, some technicians believe that holding that fiber in place, embedded in the coating, can allow that blade more time to dig in as it passes over slowly. So the point is, since that coating is going to always affect that cut score, they will always use a section of the glove that has that coating on it. Okay, I mentioned that gloves that have those fibers that have been proven to dull that COOP wheel, the round wheel, the EN388 is going to use that TDM 100 machine as well. So this is a good thing for us. This gives us more of an apple-to-apple comparison, so it makes it easier to look at those two standards and really see what we're getting. But there's some subtle differences that we still need to recognize. So let's look at the EN388 first of all. They're going to have 5 different levels that they're going to measure to. And when we talk about force applied to that straight blade on that TDM 100 machine, they're going to measure in newtons. Now, if we go to the ANSI 105, they've got 9 levels, A1 through A9. Now, up till 2016, they only went through 5 levels, but that A5 expanded after 2016 to those 4 additional levels. And the only other difference you need to recognize that ANSI is going to measure in grams as opposed to newtons when they're talking about that force applied to the blade. Now, as I mentioned, since they're both using that TDM 100 machine, like I said, now we have more of an apples to apples comparison, so this is a good thing. But the Newton score, really all we have to do is multiply that times 100 and we convert into grams. Then when you look at the two standards lined up side by side, they actually line up pretty well. So A through E on the EN388 really lines up pretty good with A1 through A5 for the ANSI standard. So as I mentioned, actually, this is a good thing that really makes it much easier when looking at either standard when they use that TDM 100 machine. Again, it makes for a lot less confusion. But once again, just to keep things a little bit confusing, that new 2016 EN388 is allowing 2 types of acceptable markings on the gloves. The second digit that is used for that COOP test is going to retain its spot. Now, remember, I mentioned that certain gloves that use fibers like glass or steel are not going to use the COOP machine. They'll just test with the TDM 100 machine. Also wanted to mention that PIP has been using the TDM 100 machine for over 10 years at one of their facilities for testing. So they're very well acquainted with this type of machine. Now, again, on those fabrics where they're going to use the TDM 100, they'll keep that placement, but they're just going to put an X there. If they were to actually score with both, those scores are so radically different, you could score as high as a 5 with the COOP test, and then only maybe an A3 with the ANSI TDM 100. So it's best, they'll just avoid that and only test with the TDM on those fabrics. They'll X out that placement. Then that'll put all attention on the 5th digit, which will be an alpha digit, which will show that TDM 100 machine. So again, it looks confusing, but it's really very easy to read and understand. Then I also added that impact. PIP is still determining what marking that they're going to go with. Okay. Now, when we're talking about cut, is it one of those things where just the higher score means that it's more protection? And unfortunately, I'm afraid it's not quite that linear. There's more to cut than just that score that comes from a sharp blade. First, there are the basics related to the materials and how they affect testing. Remember, we already talked about how glass really scores really well, although it can dull in that wheel. It scores high, even on the ANSI it scores well. Yet those glass fibers can break down and cause skin irritation. Now, in the years that I've worked in manufacturing, I've worked in glass factories and I've worked in factories dealing with sheet metal and fabrication shops, where I've got experience with all of these gloves, and I can tell you all of them work well if matched up for the right environment and the right work. For example, I've had people have really good luck and enjoy using the gloves with steel fibers, providing good cut protection. But say in that glass factory, we found that, remember, steel absorbs heat quickly, so you cannot handle hot glass wearing these gloves. And in some environments, that steel would also cause electric shock. So if we go to the glass fibers, now glass is a poor conductor of heat, so the glass fiber gloves worked really well when handling hot glass. But if they were doing something labor intense where those fibers did break down, again, people would get that skin irritation. We actually kept all these gloves in our parts room, and people did check them out. And again, each glove worked well, just depending on the environment and what you were doing with it. But the point is, we need to take into consideration all the characteristics of those gloves, not just look at that cut rating and price. We need to consider things like the fiber staple and the yarn blend. You have short staples that form a softer and more lofty and absorbing glove. Then we have that filament that is stronger and allows a blade to slide over with less resistance and hang up. Now remember, we've talked a little bit about that coating, that sometimes they can slow down the blade in that testing and actually adversely affect that score. But still, that extra coating with a rougher edge, a strong latex or nitrile, will actually help defer that edge penetration and provide better protection. So one of the things that we need to take from this is, remember, not all edge threats are the same as like the blade of a coupe machine or that TDM blade. So again, we need to look at the environment, the work being done, then take all those into consideration. So let's talk about edge sharpness versus force applied and how it really relates to injury of risk. At PIP, they became very intrigued with cut protection. They became concerned how it seemed like A7 was fast becoming the preferred cut level of protection. At ASSP, they had lots of end users actually coming up to them and requesting an A7 glove. But when they got into dialogue with them and started having them describe the work being done, they quickly determined that an A7 glove wasn't really what was needed. So PIP developed this cut risk hazard matrix that you see. And again, it really helps to guide your thinking towards more of the overall picture rather than just look at that score and price. Now on the matrix, we have a Y and an X axis. So on the Y axis, we have force. So we'll say 0 is like the amount of force needed to cut through, say, tape on a box. And 10 would be like the amount of force needed to cut through drywall with a box knife. Then if we go to the X axis and we're looking at edge sharpness, we'll say 0 is like, say, the edge of a brick. And then 10 would be like that sharp blade of a box knife. So this is more how we need to look at the whole situation. You know, how do those play on each other? And what is the actual work in the environment that people are dealing with? Now, this relative comparison, again, is how we want people to look when they're trying to choose the right glove. We want customers to think this way. And there are different examples here on the matrix. And again, they're all relative, but when you're using it like this, you're going to have a better chance of picking that right glove. And when working with, say, PIP, they've got their catalog set up to where they've got the different gloves that fall in the various quadrants that, again, help you to make the right selection. Actually, they have a tool I'm going to jump to quickly that I've had way too much fun with. So if you pull this tool up, you can actually toggle this over. And here we have our cut risk hazard matrix, and you see those examples on it. Now, if I pick one, we'll pick this one right here, where again the cut with tile and glass work, I can go over here, grab this, slide it over to this area, and we got a 7.7 for our rating. And you click on that and you've got some different gloves that you can choose. Here's 21 different types. So you can click on that and you can actually narrow your search. You can actually scroll down and we'll go up a little bit here. See if I can do it, not click us out. But yeah, on this side over here, you have different ways to narrow your search. We can go to coated gloves, and actually here with all the information that we really need to know, but it's all right there. So again, just an excellent tool that PIP has provided. If I'd have had this back when I made my mistakes, then it probably would have given me a lot better direction than just trying to go out that label and the cut score and the various things that we're telling you not to do. So my mistake was just a teachable moment for others. Now, again, let's go ahead and we'll look at some different gloves to see how we do have really some very good gloves to match with the type of industry, environment, and work being done. So we'll just quickly look at 5 different gloves here. This glove is a very lightweight glove. It has an ANSI cut rating of A1 and an EN 388 rating of an A. And I've had really good luck with this type of glove. This glove would be excellent for general assembly, something where people have to handle small parts like nuts and bolts, micro engineering, painting, automotive, horticulture. This glove works really well. In environments where I've had employees using this glove, I noticed that between tasks where they could remove the glove, they left it on. Now that told me we had a really good glove that people didn't mind wearing. It's very comfortable. So I didn't have to remind them to put their PPE on. So again, it's a very good glove. Now we're going to jump to kind of the other side of the spectrum and look at something with a high cut rating. Here's a nice G-Tech polycore blended glove. It has an ANSI A7 rating and for the EN388 and F. So a pretty significant cut protection here. So this would be something you'd be using if like dealing with something where you had those sharp objects that could really provide a cut hazard. Good for general duty, again, assembly work, construction. Has that neofoam coating, again, which helps with wet dry grip. And a lot of the gloves we're going to look at are actually touchscreen compatible. That's something you might want to consider. A lot of gloves with coatings are not touchscreen compatible. And we live in a digital age. So if you've got your people using iPads or interacting with touchscreens, again, this is just another option that you might want to consider looking for. But you can see how the different gloves, there's almost always a glove that is a good fit, no pun intended, for the work being done. So again, it just takes a little time in the research, but you can match up the glove and the environment and the work pretty easily these days. So here we have a medium, I'd say medium to lightweight glove, and this is another type that I've had really good luck with. I noticed with people that were wearing this type of glove that it was comfortable. They could handle small parts and tools with it, and they would not take it off in between tasks because, again, it was a comfortable glove that they didn't mind wearing. So again, good for dealing with oily and wet parts, has that wet dry grip, again, touchscreen compatible. So a very good glove where if a person needs dexterity. Again, ANSI A2 rating, EN 388 of a B. So a really good glove. Okay, the next glove we're going to look at, this is the type of glove that you would use, say, for finishing and inspecting work, general duty maintenance, small parts. It has pretty good cut rating. It's an ANSI A4, an EN 388. It's still a lightweight G-Tech glove. And again, it has that good neofoam coating, so you can work with a wet or dry grip. And this one is actually compliant, again, with FDA food handling. So once again, we get pretty good with targeting the type of glove that's needed for the field and the type of work that we're actually doing. The last glove that we're going to look at here is another G-Tech glove, polycore blended shell. And this is the type of glove that I'm probably most familiar with when I was working back again in the glass industry. So this was the type of glove that we had people wearing to, again, just protect them from that glass. Pretty good cut rating, ANSI A5. EN 388 was an E. So pretty good glove all around. I like, again, it's the coating gives it like tiny suction cups. So if you're dealing with oily or wet parts, it is a very good glove. Now, this is also a washable glove, and for us, if someone had a glove that wasn't worn out but just got dirty, got oily or whatever, they could turn it into the parts room in the glass factory I was working at, and we'd actually rewash them and check them out as a used glove. So again, these gloves did extremely well for us, and we got a lot of life out of them. And we were able to put fewer and fewer Band-Aids on Superman's hands. So it was a good win. So really, that's a lot of information. Hopefully, this gave you some better direction in being able to understand the different characteristics of the gloves, including what the fibers are, what they're made out of, looking at the right coating, being able to match up the glove for the task. And reach out to the professionals. Most of my experience is as an end user and trying to find the right glove. So I constantly reached out to people like PIP and the true experts that could help me to fill in the blanks when I did have questions, so that I didn't make more mistakes and have to change what I had chosen for the gloves. So with that, we'll go ahead and take any questions.
Thanks so much, Brian. Great job. Let's see here. Gary, Gary, can we hear you okay? If you can just
I should be live.
Awesome. Yeah, can hear you loud and clear. All right. Thanks, Brian. Great presentation. Lots of great questions came in, both during and prior to the webinar during registration. So let's get started. Robert has a question. Why are European EN scores printed on US gloves? Why not just show ANSI?
That's always a good question, and people always get confused with that because the EN scores have changed so much. It does make it a little confusing. We should just be using ANSI over here because we're in the U.S. But the EN scores are key because they give you more information than just a cut. There's 4 numbers under that EN 388 score: abrasion, cut, tear, and puncture. ACT professional is a good way to remember that, ACTP. So in addition to the cut, it also gives you abrasion, which a lot of people ask about, cut, tear, and puncture. And then with the new scores, you're adding in a different cut test using the TDM 100 and also an impact test. So it's more than just cut. I will tell you, too, that ANSI is a compliantary standard. You do compliance, while the EN 388, the European standard, they demand you test from a third-party testing. Many people here in the U.S. still use third-party for ANSI, but not everybody. So just keep that in mind. When you see that EN score, you know it's been verified by a third-party source. I think that's why you see it. Plus, the EN 388 has been around longer than ANSI, and people are used to that. So when somebody out in the field goes, I need a cut 3 glove, you got to ask them, do you mean the EN 3, the old ANSI, or the new ANSI A3? That's always confusion out in the field.
I guess that's why Brian was having trouble getting the right cut gloves at the lighting factory.
I don't feel so bad.
Awesome. All right, here, let's see. Aleli has a question. In of our task, the operator cleans a very long, sharp-edged piece submerged in thinner. We are currently using a chemical-resistant glove, cut 1, over a cut level 5. We were able to source a cut level 3 glove. What should the inner glove's cut level be? A level 5 still, or can we lower it to a cut level 2? Pretty specific question there.
That's kind of a tough one to do because I always say on a cut level glove, it depends on the application, but also the grip of the glove. Here you've taken the grip out by putting something over it, so the grip doesn't play an effect. I would suggest looking at that cut risk hazard matrix, and judging the force you're using versus the sharpness of that blade, and try to come up with the cut level needed. And then you're going to still throw that chemical glove over it too to put it in the thinner, I believe. So that's kind of a tough one. You wouldn't need a coated cut resistant glove in that scenario.
Thanks, Gary. Let's see. Taylor has a question. I have a customer that necropsy cattle and currently use a steel chain glove, but also need to wear a high puncture glove underneath while also be thin. Any recommendations?
Steel chain glove. I need to wear. Boy, the puncture score again is that fourth digit of the EN 388 score, and that gets you to a whole another style of glove that doesn't necessarily relate to cut. So I would, if you need punctures important, and I don't know what type of puncture that is against wood or something like that, look for a glove that's got a higher puncture score. And usually that's a very specialized type of glove to hit an EN4 puncture rating. That's kind of tough. That's really not a cut question. Cut doesn't always give you great puncture, just FYI.
Oh, that's great. Great to know. Thanks, Gary. Let's see here. And Daryl asked this question before. It says, do you have a cut glove chart? So yeah, the cut glove matrix is a fantastic tool. Had a few comments that what a wonderful tool it is. I'll send out a link on Monday when we send out the recording. I'll send a link to the cut glove matrix for everybody to have. So thank you, Daryl, for your question. Crispin asks, there's always a cut resistance for palm. How about the hand dorsal? When mechanics put in place their hands where there is possibility of abrasion, what can you recommend for that?
That's a really good question, and Brian kind of covered a little bit. People don't really understand where the cut score is taken from. It's really taken from the palm. Why? Because that's the most common place you'd be cut when you grip something. And the cut protection is in the liner of the glove. It's not the coating, as Brian said. The coating really, it could add a few points, but it could also take away a few points. The coating isn't the part that gives you the cut resistance. It's the liner. So hence they take it from the palm because that's the most common place you'd be cut. So the liner extends from the palm of your hand all the way around to the dorsal side. Your cut protection is all over your hand of the liner. It's not really the coating. There's a couple people out there that like cheat and do like no cut protection on the back of the glove, which is really weird. They do that to get a lower price, but those gloves are few and far between. So the cut protection you're getting is from the liner over the whole glove.
Great, thank you, Gary. Let's see, Steve asks the question, are you aware of any active enforcement efforts by OSHA?
Boy, Sheila, maybe you know that one, but really, I don't think OSHA bothers you too much on hand protection. That's brought up in our training seminars sometime, and I hear very little OSHA comments on hand protection.
Yeah, usually OSHA is not going to dig into that level. Again, they can throw out that general duty clause, but they're going to, if you've got hand protection and you've looked at, again, the risk, the hazard, and have that control measure being the glove. I'm with Gary. I haven't ever seen OSHA really dig into that level.
I think OSHA just says you have to provide it and make it available. That's about it.
Yeah.
All right, here's a question from Tamara. That's a great question. Is there a difference between gloves for each gender?
Boy, that's interesting. Basically not. No. They pretty much, on seamless coated gloves, it's a set former that you have that just basically does the 4 sizes. So there isn't a gender difference like there would be for eyewear or something else. Basically, you'd just be grabbing different sizes. And unfortunately, those sizes you see out there are mostly men's sizes.
All right, thank you, Gary. Tom has a good question. What about arc-rated and cut-resistant options in gloves?
There are arc-rated cut-resistant gloves, both in a coated seamless knit as well as certain leather drivers that offer arc rating protection. So yes, you can find them from PIP or other competitors, yes.
Great, thanks, Gary. Great question, Tom. Let's see here. Sean asked a question. What sanitization processes are best for the longevity of the glove? So talk about washing and sanitizing and that kind of thing, if you can, Gary.
That's the best thing to do. And we specify this in all our spec sheets for gloves. But basically, you just throw them in the wash and just wash them carefully. You using water is the best. Soap and water is the best. And, obviously you're going to be able to tell when it's no longer there. I mean, the coating will go probably before you ever see anything on the liners. So, but that's just regular washing is the best way to keep those clean.
All right. Jason has a question here, and forgive me as I try and get through it. So he's got some winter gloves, and they only have the EN score on there, the rating. When the gloves are tested, is the glove put on a fake hand? And for winter gloves, would the liner be included? Two-part question. What about leather gloves? Do they have these ratings? I've never seen it. Thanks, Jason, for the question.
The winter glove question is a good one because, as Brian mentioned, when they do the testing, they actually cut the glove up. It's a 2-inch by 4-inch strip right in the palm. So to do a winter glove, it typically has 2 liners. You have to kind of put the liner below the other one. You can't test them separately and add the 2 together. So the labs hate testing winter gloves, but it is tested through the whole palm. And usually that terry on the bottom will make it tough to go through and actually connect. But it is, both layers get tested together. You're not allowed to test them separately and add them together. Leather gloves, you don't see these ratings because leather is just dead animal skin. People think leather gives you cut protection. It offers basically no protection. Leather gloves, that's one of the reasons that cut-resistant gloves are increasing so much is people are coming over from general purpose gloves and leather drivers and leather palms because they need some sort of cut protection. So they use an A2 or an A3 glove from leather because really leather drivers offer no cut protection.
And just a comment back from Jason, he says, thank you, that is exactly what I was looking for. So thanks, Gary. Michelle has a question. Why did ANSI go from 1 to 5 to an A1 to A9 scale?
That one comes up, before 2016. ANSI did, had only 1 to 5, and people said, why did they go to A1 to A9? And the reason was the technology, the glove cut technology got so much better. PIP alone has done things called Supreme and Polycor Cristal, and now these gram scores keep going up, and you just can't say it's at level, X thousand or higher as a 5. We needed more scores to differentiate between these gloves. So we needed A7s are different than A9s and things like that. We needed more levels. And you could see that was important because the EN European people looked and said, you know what, we have to do the same thing. That's why they changed their test method as well. And one thing this brings up is people, when it was 1 to 5, people said, I need the middle. I need a 3. Okay, that's not really true. You need to have the correct cut score with the correct grip. But now that it's A1 to A9, they do the same thing. They go, well, I need an A5 because that's the middle. And that is just not true. An A5 is still quite a bit of cut protection. And don't forget, as you go up in cut protection, you're paying more here. So your counselors to your people, it behooves you to pick the correct cut level and the price. So you probably don't need an A5. That isn't the middle anymore. PIP probably sells more cut gloves than anybody. We sell mostly A2s, and then you sell some A3, A4s, A5s, all the way up to A9s. So don't, think you need the middle cut protection. That's why that cut risk hazard matrix is so important. That tells you the true cut level you need for your application.
No, that's great. Thanks, Gary. And you just answered Mike's question. I think you just said A2. It said, if the scale goes from A1 to A9, what is the most common cut glove sold?
Yeah, exactly. People assume they got to be in the middle to be an A5, but an A5 cut level, that's like 2,200 grams or higher. That's quite a lot of cut protection. You just need the proper cut level with the right grip. Again, if you have the right grip, that material's not sliding through your hand, that minimizes your cut risk hazard right there. If you have the correct grip, it's not sliding through your hands, you're not going to get cut. So you don't necessarily need the higher cut level. You need the correct cut level with the proper grip.
And correct me if I'm wrong, I noticed when Brian was going through the cut matrix tool, cut is one factor that you have to think about. But there I saw like oily or wet or dry wet. Can you talk a little bit about, I know we're talking about cut protection here, but what is the job that you're doing? That cut matrix seemed to imply that there's a lot more to think about than just cut protection.
Exactly. It's almost like a third axis goes through, because if you're handling oily material, then you might want a nitrile coating or a neofoam coating that has like little suction cups on it that can handle the oil much better than something like a latex or a PU. If you're into construction, they use typically PU, polyurethane coatings. They like those because they get good grip for what they're working on. And certainly the grip certainly factors into the cut level you need. You need the proper grip for the application.
Awesome. Thanks, Gary. Steve has a question. How much do environmental conditions, cold or heat, affect the performance of the glove?
As far as cut levels, they should not. I mean, ANSI does require the gloves to be, at a set controlled temperature before testing, just like they do on a hard hat or anything else. But really affecting the cut levels, that should not bother it. Where cold temperatures could affect the glove are the coating. The coating can get less flexible as you get below 32 and below 0 degrees, and the glove gets stiffer, and that would affect your dexterity, but that would not affect the cut level of the glove.
Great. Thank you, Gary. Hey, and correct me if I'm wrong, does PIP, and this could just be a flat no, but do you guys have like a glove to use in hot weather? Am I dreaming this? Like for like a cooling glove or something like that? Did I see that?
Yeah, it depends on the glove liner again. We talk about gloves with 360-degree breathability, because you only get cut protection when that glove is on your hand, so gloves have to breathe a little bit. So we have certain styles, like from ATG and some of our own Polycore styles, that the gloves are just more breathable on your hand, even through the coating. Like if you wore a PU coating does not breathe as well, you put that glove on and it's a hot weather out, your hand's going to get uncomfortable. But if you pay a little bit more for the ATG or some of these Polycore styles, the gloves breathe better and you won't feel that need to take it off at some point to let your hand dry out a little bit.
I see. Thanks for the clarification. Sherry has a question here. It says, we are looking for one cut level glove for general industry. Is there a recommendation cut level I should be stocking? We have sampled multiple cut levels, types, and brands. I was looking at an A6 from one brand and an A7 from another. These were selected on comfort, dexterity, and grip by my employees. I need to explain to the rest of the team why we ended up choosing the A7 over the A6. Just wondering if there was any standard for cut level for many applications. And maybe that's
wow. An A6 or an A7 is extremely high cut level. I wonder what they're handling. And typically, as cut levels go up, your dexterity goes down. I mean, it just kind of makes sense. They're using, steel and other materials in the gloves when you get above an A5 to give you that protection. My answer was, when you first asked the question, the answer is it's an A2. I mean, we sell far more A2 gloves than any other cut level because that's general industry. The joke is that the new general purpose gloves are just gloves that you use for handling and things like that, is now an A2 cut, because the price on cut resistance has come down so much, you might as well buy everybody an A2 and give them that light cut protection. So I would say that. I mean, I don't know why you're using an A6 or A7 unless you're handling very sharp, heavy objects. But if I was going to stock one, I would start with A2, go A3, A4, and maybe add a couple of A6, A7s for the specialized people that need that really super protection.
Yeah, that makes sense. I just asked Sherry if she could clarify. So Sherry, if you're out there, let us know. John has a good question. Appears John is from Canada. Oh, Canada. What levels would these compare to CSA Canadian ratings? Or does Canada use the EN standard?
The Canada basically uses the EN or the ANSI standards. There really is no difference there.
Okay, and John, if you're seeing something different with different cut protection levels on a glove, just let us know. Garrett has a good question. What cut level can I get before it starts to really affect dexterity? Specifically, our guys are mechanics and won't wear a glove if they can use their fingers to tighten bolts and things like that. If you could please talk about dexterity.
That answer is changing every day as PIP and the other competitors, out there improve these gloves. We just launched an A7 cut glove, very high, but it's an 18 gauge glove. It gives you incredible dexterity. So you could tighten nuts or bolts up easily with that. But that's, using kind of like funky liner to be able to do that. So that answer is really changing all the time. Watch the gauge of the glove. As you know, as the gauge goes up, the glove gets thinner, meaning it gives you better dexterity. So typically when cut levels go up, the gauge goes down in number because you're using thicker fiber. But nowadays with the technology, we're able to do even an A7 and 18 gauge, which is incredible. So it changes every day.
Great, thanks. Actually, and Stan had a similar question. Is it possible to obtain liquid protection and A4 cut protection without sacrificing dexterity?
Almost the same answer there. To get the liquid protection, we're going to take that cut level glove and do a full dip, right down to the wrist, be it a latex for water protection, make it almost waterproof, be it nitrile to give you oil resistance so the oil doesn't touch your hand. And that really should not affect your cut level at all, as long as we have a good grip on that glove. And certainly you can do an A3, A4, A5, even in an 18 gauge still and get great dexterity. The liquid resistance is really a function of the different coatings we have. You have a full coating, a 3/4 coating, or a regular palm dip that you see.
Right, thanks, Gary. Sherry did clarify. She works at a power generation facility. The employees handle things like heavy sheet metal objects, many times with jagged edges, handling classifier vanes with razor sharp edges. So it sounds like the level of
they need the higher cut levels
there.
Absolutely, yes. So her general glove might be an A5, A6, A7 just for basics.
And maybe Brian, you could touch a little bit on this, but I know PIP, you guys, along with yourself and your distributors, do hand protection assessments, because it is common, and just listening to Brian, that, based on the worst case scenario, you purchase a whole bunch of cut A7 gloves, which are way more expensive when it is just those, few employees that are in those dedicated tasks that need the A7. Everyone else might get away with an A2 or A3. Brian, can you talk a little bit about that?
Yeah, and actually the last industry, the last factory that I was working at helping with safety was a company that rebuilt transformers. So they were working with a lot of metal and fabrication, and probably the number one glove that we used was an ANSI A3. So that provided, really the type of protection they needed for most work. Then again, we did have some higher rated gloves available if they were doing something special where they were, say, upping the threat for cut. But like you just mentioned, going back to, say, my glass factory days or working as a safety manager, I would, if I wasn't sure, I would usually contact the distributor or the experts like PIP, try and get a hold of someone like Gary, that and just describe what you're dealing with, what the environment is. And they were, it's always an expert usually that would direct me in making sure that we had the right glove. And as a matter of fact, I had several times where, like I said, an individual will come in and actually look at the work the people were doing. And so they could tell me, hey, this is the glove that I recommend. And one of the things I appreciate Gary mentioning is how much this industry changes so quickly. Again, if I go back to the glass factory, in 2008, some of the gloves that we wanted were kind of high in price or hard to get to fit our needs. But within a couple of years, they were available in different styles, and just that technology changes so quickly. And I really relied on our distributors and vendors and the experts to keep me abreast, with any changes that, hey, for what you guys are doing, now we would really recommend this glove. Because again, the better you do at matching the work and the comfort level for the individuals, it's a win-win-win. If you can find that glove that's comfortable to wear, that will protect them, then again, it's a win-win for everybody.
Great. Thank you, Brian. Steve has a question. Given how rapidly technology is advancing, how often are the cut rating specifications reviewed and new testing done?
We at PIP, we have two people that sit on the ISCA committee for hand protection. And basically what they do is they review in their meetings twice a year, what's happening with the industry and what's happening with technology. And basically that standard is kind of rewritten or reissued about every 5 years. It's tough to get changes in place, but they do talk about this twice a year. And that's why they made the big change to go from 1 to 5 to A1 to A9. That was huge back in 2016. So it's reviewed continuously, and they do try to react with the best interests of everybody in mind.
Great, thank you, Gary. John did follow up about the Canadian. He mentioned they use ANSI. Thanks, John, for following up.
Perfect.
We have a couple industry-specific questions. So Lewis right here has a question. For roofers using and installing metal, what do you recommend, A3 or A4?
Again, I recommend that cut risk hazard matrix, just to really look your edge sharpness versus, how much you're touching it, and try to pick something there. A3, A4 generally sounds about right. That stuff can get pretty nasty. And again, the key thing there is you want the right grip again for that, so that's not sliding through your hand and is going to cut you in the palm. I mean, the grip is very important there, I think.
All right, and Garrett has a question. Our welders use a lot of leather gloves, and now I understand that they do not have any cut protection. What would you recommend for welders?
Welders or the other people that love their leather gloves, because they just want that grip of leather, we've started to take leather gloves and add cut linings to them. And we certainly do this on welding gloves. So you still have that traditional outside goat skin or cowhide leather, and they have a Kevlar or aramid lining sewn inside that gives you their cut protection. And again, when you cut test those, you take that palm area again. Really, that cowhide or goat skin isn't giving you any cut protection. It's the aramid liner that's inside that gives you the cut protection. And those can go anywhere from A2. We just came out, up to A7. In fact, we have an A7 cut glove that's basically a coated seamless knit A7 that we've basically sewn a cowhide palm on the front of it. So they get that grip of cowhide still, but they're taking advantage of the cut protection of a coated seamless knit.
Awesome. Thank you, Gary. Let's see here. Jim has a question. We work with industrial insulation. We work with wire and cladding and stainless steel. We require dexterity. What glove would you recommend other than the Matrix?
Again, the Matrix is going to tell you that. Let's see, for wire and cladding steel, stainless steel, dexterity. Boy, it doesn't sound like you need a high cut level there. Again, you just need to worry about your grip. We have so many different styles. I'm trying to think how to narrow it down. You probably need a low cut level with some sort of good, depending if it's a latex crinkle grip or whatever the grip you need for that application.
No, that's great. Thanks, Gary. And so the common denominator here is if you do have a question of which glove should I use, go to PIP's website. We'll be sending the link out on Monday, but start playing around with that matrix tool, the selector. It should be able to help you find, and correct me if I'm wrong, there are hundreds and hundreds of different gloves that PIP manufactures, so you should be able to find the right one for your application. Let's see, rotating machinery. Interesting. What glove works better around rotating machinery, such as grinders? That's an interesting question.
That's a tough one.
In my experience, I've seen sometimes it's best to not wear gloves at all with certain rotating machinery. I know that's not a one size fits all, no pun intended, but I've worked in different industries where it was mandatory that you didn't wear gloves to keep warm and that kind of thing because of the rotating machinery could
Yeah,
catch the glove.
if that glove presents an additional hazard where it could be grabbed by something, then yeah, typically you would not wear a glove in that. But it's one of those again where I hate to make a cover statement like that. You really need to look at the equipment, the task. But you're exactly right. There are some jobs with I can think in lots of different manufacturing environments I've been in where there's definitely a snag hazard if you were wearing a glove. So when operating certain equipment, you really wouldn't wear the gloves.
Yeah, that's a tough one to answer without a glove assessment because you need a thicker glove because you're worried about cut as well as abrasion, obviously, depending on what type the grinding wheel is.
Yeah, definitely the glove assessment is a good idea. Robert has a question here. We had an employee working from a lift that was securing a piece of pipe with one hand and was holding and operating a Sawzall in his other hand. As he started cutting with the Sawzall, the blade jumped off the pipe and briefly touched his hand that was securing the pipe, causing a laceration. Are there any gloves that would be recommended for cut protection against a quick, unexpected encounter with a power tool like this, like a Sawzall?
That's actually a good question because it lets me say something we try to emphasize in training all the time. These are cut resistant gloves. They're not cut proof gloves. I mean, you can always get lacerations, even theoretically on an A9. You could still come through in a circumstance just like that. They can only do so much protection. They're cut resistant. They are not cut proof, unfortunately. We have yet to develop that one really. Even the chainmail gloves are technically not cut proof.
Grant has one more question, and it appears that it is the last question so far. So if you have a question and you want to get it in, better get it in right away. So Grant's question is, he mentions it's an interesting question about the cut resistant under a chemical glove. Would cut resistance over chemical be better? And I think you mean wearing it over the chemical glove, essentially, or chemical protection. Can you talk a little bit about the multi-purpose?
That would be kind of tough to do, really. But I can tell you on our website we do have a selection of chemical gloves that give you light cut resistance. I believe an A2 or an A3, where we've combined the best of both worlds. But almost mimicking what the first person said, where they had basically a cut liner on the inside of a chemical glove, trying to get the best of both worlds.
Thanks, Gary. All right, well, it looks like there are no more questions. Really appreciate everyone. Brian, any final remarks before we close out the webinar?
No, again, I'd like to thank everyone for tuning in, and a special thanks to PIP for providing this information. It's one of those that I really learned more myself, even coming across their risk hazard matrix. Again, what an excellent tool, and resources are so valuable. So hopefully, if nothing else, we're giving everyone a great resource to help guide you when making these decisions. And thank Gary for bailing me out. I don't think I could have answered any of those questions. So thanks for being the technical man on the spot. I appreciate it.
Gary, any final remarks before we go?
I think we're good. We've covered most of the questions that come up in typical trading, so I think they were very good questions, and hopefully we enlightened everybody on cut protection a little bit.
Thank you, Brian, for a great presentation. Thank you, Gary, for answering the questions. Thank you, Sheila, behind the scenes. Great job putting all this together. Thank you to PIP for making this possible, and Safety Network. And most importantly, thank you to the audience. We really appreciate you joining us today. We realize you have a choice of where to spend your time, and we're grateful that you spent it with us. So with that, have a great week, everybody, and stay safe.